Well, hello everyone. On the bench today we have a B&K E200D. This is a RF signal generator that was sent in by a viewer. Now he has restored the inside, but he's got a problem with it, so he sent it to me to take a look at it and see if I can track down this issue. As he said, you know, his generator works real good, but you might can hear that. You can hear a little static, like a little static crash pops in the speaker. So there's something in the audio section that is yeah, I can see it on the VU meter. So what we want to do is get in here today and see if we can figure out what this noise is and what's causing this problem for them. Now I'm looking at it on the spectrum analyzer and on the oscilloscope, and you can see the oscilloscope just wiggling around. So the noise is on the output signal also. So whatever caused it is going all the way through the amplifier section. You can see the spectrum is pretty stable, but the scope is, every time the noise comes through, you'll see the scope jump. And it's not doing it all the time. I'll give it a little tap test. So it doesn't, you know, appear to be microphonics, but you can see it jumping around there. So let's go ahead and get the case off this thing and get in here and take a look and see if we can figure out what's going on. Okay, I went in and took all the covers off, and it's not hard at all. You just take out a few screws and the top comes off, and then you have a couple of screws here. I went ahead and removed the RF shield from the oscillator assembly, and right now it's I think y'all can hear that. Quite a bit of noise, but you know, the job that he's done to it looks great. He's installed a new 3-wire power cord, used a standard computer style chassis connector, which I had to unbolt that from the bottom chassis and just leave it connected. Yeah, but you can hear the noise. And the first thing I seen when I took the cover off is the ball bearings in this variable capacitor. Zoom in on that. I don't know how well y'all can see that in the camera, but it's got that old grease in it. Quite a bit of old grease in the thing, and it's hard and dried up. So we'll need to clean both ends of this variable capacitor and re-lube this, which I don't think that's where the noise is coming from, but it wouldn't be a bad idea to do. But I noticed that when I play with the band selector switch, you can hear the noise gets worse. So there's two wafers here. Now I'm not sure if the owner, when he recapped the rig and went through it, if he even took this cover off. I didn't know, he didn't say. But the reason why I was saying that is I noticed there's one electrolytic here that it looks like it's still original, that hasn't been replaced. So we'll go ahead and replace that. We'll clean out the ends of the variable capacitor and relube those, and then I'll clean this band switch and this control and see if that helps get, you know, some of that noise out of there. We just have to, you know, play with it. I went through, I used the ICO 150 solid state signal tracer on the output of the speaker and turned the gain wide open. I went through with this little rod and tapped all components and moved all the wires around to see if it would make any more noise, and it would not. It just got this random noise in it, so I couldn't find no loose components or loose wires. You know, a lot of times you might get a noisy resistor or component, and what it is where the lead, where it enters the body of the component, it's breaking down, and sometimes by just going in here and, you know, taking a resistor and moving it, you would be able to hear that noise, you know. But I'm not finding that in this. So let me go ahead and clean these two areas here and see can we get this electrolytic replaced and clean this other control, and we'll see if we've eliminated this issue. Well, after cleaning all that up and replacing that cap, the noise remains. And you can see it sometimes. I mean, just a moment ago it got real bad, and before I could get my probe on it, which is doing it now. So what I'm going to do is disconnect the hot side of the speaker so I cannot hear the noise from the unit, and we're going to take the signal tracer and trace out through the circuit and see if we can find out where the noise stops right at. So just, you know, disconnect the speaker, that way we ain't hearing it on both sides. It's easy to listen to it through the signal tracer. Okay guys, the unit's sitting here running, and it's basically pretty much quiet. But I got tied up doing some other things, running back and forth between this and some other stuff, and I got in here looking, and I noticed that there was a resistor here that was missing right up in this area, and you can see the resistor there. I have reinstalled a new one, and when I reinstalled this resistor, the modulation quit working. So I start checking around and looking, and over here is Q9 and Q10. Now these are the oscillator circuit for the modulation. Q9 had been changed out with a different transistor. So hard to see. A 2N5458, and I think the originals are MPS 5613 or 6513. So the pinouts is completely different on this transistor, and they had it here in the place of Q9. Well, I pulled it and I replaced it with a 2N2222, which is a compatible to the 6513, and now the modulation is back working like it's supposed to be. See, there's the bass, there's the collector output, so we got plenty of gain there. And when I did this, all the noise has quit. I'm hearing no more popping and snapping from the speaker, and no static, know anything. It's been sitting here running for about 30 minutes while I was doing some other things. So perhaps, you know, this transistor at Q9 was the culprit the whole time. It's, you know, kind of flaky that it's like that. Now I got to go through and touch up all the alignments because I sprayed deoxit in these resistors and moved them back and forth, so the alignment's off a little bit now. But you know, I was just searching, trying to define the noise, and taking the signal tracer, you know, and just going to every component in here and trying to find any component that was making this noise. And when I checked the base of this Q9 that was in here, there was a lot of noise in that signal that was on the base. There was nothing on the collector output, so that went ahead and told me that transistor that was installed was not correct. And it looks like somebody had played around with this and removed this resistor to make this thing work somewhat, but it's working as intended now. So I'm going to sit here and run some more, and I might have to take the board out and touch up some solder joints behind it and just let it run and see what happens. Okay, since I was able to go ahead and get rid of the noise that was in this generator by replacing a component and adding a component, the noise is gone. Now, it is normal sometimes to hear a little pop or a little static in the unit when it's just sitting here. That's going to happen sometimes. It's just the nature of the way these things are designed. But mostly, if you got all the shielding on, it should eliminate most of it. But you will still hear a little bit from time to time. But what I want to go ahead and do is align the unit, and we'll start by aligning the bands. And on this unit, it's like some of the receivers, like the Hammerlands and so forth, where you align the bottom and top end of the band. It's just not one setting for the band. And this is done through this little hole here in the back. You pop this cap out and you can get in here and start. Now you see this one screw trimmer here, that is for band A, and then B, C, D, and E. And back behind it down in here is also some coils, and the coil that's right next to this one is band A, and then it's in counterclockwise and it follows the band position. Now here on the alignment, you can see the coils and you can see the slugs that are down in there. The coils that are down in the back align the low end of the band, and these screws align the top end of the band. So we'll go ahead and start with band A, and we'll go ahead and get it aligned. Okay, I got the generator set on CW. We're in carrier position. I have the attenuator all cut off on the main attenuators, and the fines at about 12 o'clock. We're on A band and the calibrator's off. I've got the dial set for 105 kilohertz. Now we can see the frequency counter and the spectrum analyzer, and on the frequency counter you can see it's 105.40. So we're going to adjust this a little bit. The other way, you see that the spectrum analyzer is moving over, And it's just a little bit touchy trying to get it spot on. But there we go, 105.00, and the spectrum analyzer agrees with that. Okay, we'll go ahead and move up to the high end of the band. And we're going to set the dial for 360 kilohertz. And the frequency counter shows 361.2. We'll set the frequency 360 kilohertz. We have peak on, and we'll set the span for 20 kilohertz. And the spectrum analyzer showing about 361.2, and that's about the same as what the frequency counter is displaying. Now this time I will go to the screw terminal on the top and adjust it. Overshot it just a little bit. And that's pretty much close enough. As you can see, we're right on 360.0 kilohertz. Alright, now we're on band B, and we should be at 380 kilohertz. That's what I have the dial set to. I'm going to get my alignment tool in there. It's a little dark in that hole. And you can see we're very, very close already. But nothing wrong with getting it spot on. .79999, and the spectrum analyzer is showing 380, so that's good, close enough on that one. We'll go to the top, which is going to be 1350 kilohertz. At 134935, we'll set the spectrum analyzer. Frequency 1350 kilohertz, and turn the peak on. It's about the same thing. We're a little low on that frequency. Which is going to come out with our screw. Very, very touchy. And that's pretty close. I'm not going to bore y'all with setting the other bands. I just want to show you how I do an alignment. I'm using the frequency counter and the spectrum analyzer to look at everything. It makes it a little easier. You got a number and you got a visual to go by. Alright, so this is why I use the frequency counter plus the spectrum analyzer. I'm setting band D high end. It's supposed to be 15 megahertz, and we see we're at 14.938333. And this would be center span, where 15 should be. So it's real easy just glancing at the spectrum analyzer and moving the peak right where it needs to be. And then looking at the frequency counter just to verify the numbers. Now I can fine tune this a little bit, get it close as possible, and that's just barely touching it. You see it's 15.00333, and if we look at the frequency counter, it shows the same thing. So yeah, you have to sit down and play with them. On the higher bands it's a little bit more touchy. I mean, just touching the screw will cause you to overshoot. And that's the best that you can get it, because when you turn that screw, it's like it's trying to turn the whole little fixture. So it makes it a little tough. But yeah, this is why I use both the visual, the spectrum analyzer, and then looking at the frequency on the frequency counter. And in fact, you know, it's a little bit easier to see the frequency counter once you get to that last fine tune of it. I thought this was worth mentioning. This is the sine wave. I'm putting a 50 megahertz signal into the Rigol oscilloscope, and you can see how crisp and clear and sinusoidal how this waveform is. Now if you notice, a lot of the other signal generators that we've worked on in the shop, especially some of them older tube type generators, you remember, the waveform is never perfect. It's always got some ringing on the ends or distorted looking signal. But the B&K E200D does a good job at producing a clean signal. You know, it's not bad at all. So if any of you out here that's got one of those older tube types and want something a little better, the B&K 200E or 200D is a little bit better choice. It's a more modern piece of equipment. Now it's not perfect, it's got some issues with them too, you know, but hey, it's got a clean signal. Now when you're adjusting the modulation and on the meter, you got it set to get it set to 50%. You want about 2 divisions on the lowest points and 6 divisions peak to peak on the highest point. When you have that achieved, you can then adjust R54 so that the meter on the front of the unit will read 50% modulation. And we got it right on 50% modulation. It's a little bit tough sometimes. You have to go in, you have to play with R49. You might have to lower the value or raise the value to get the peak to peak to read right. This one is so close that I'm not going to worry about bothering that, but it is reading about 50% modulation. Well guys, the B&K E200D is working quite well now. Still hear no noise from the speaker, and the output level looks good. I didn't take the time to show the calibration of the output signal. It's in the manual if everyone ever has to do it. It's not hard to do. You just need to convert millivolts to dB, and I used the spectrum analyzer to check it, and it's pretty much spot on, so I didn't have to do an alignment on that part. Everything else working pretty good. Crystal calibrator seems to be working great. So yeah, that's seems to be holding up good. Now what I'll need to do is just I'll set it over on the other workbench, plug it in, and let it sit there and run and burn in for a day or two, and see if any of that noise comes back while I'm out here in the shop working. You know, you never know if there is still something in there that could act up and cause a noise, but once I replaced that transistor and added that resistor, I haven't heard the noise since. So it's doing what it's supposed to be doing. As you can see, it's quick, easy, wasn't a whole lot to it. You know, just to get in there and get everything right. Real easy piece of equipment to work on, and it's pretty good, stable. Again, like I said, you know, if you have an old tube type generator and want to go to something a little bit better, the B&K solid state E200D is a pretty decent choice. So okay, I hope you enjoyed the video, and I hope it taught you something, and until the next video, we'll see you later.